rocked Fresno this morning. The good thing is the quake was not real. It was a test at Fresno State to see how well historic buildings can hold up in case of such an emergency. Full-scale masonry walls were built in the structural testing laboratory on campus for the project. Engineers were testing the seismic resistance of the buildings with epoxy and environmentally safe resin that doesn't use illegal propellants. The epoxy is used to strengthen older, historic masonry structures before an earthquake occurs and to repair any damage caused after a quake.
An in-plane shear test simulates the horizontal movement produced by an earthquake. It's the last of a series of tests.
The epoxy turned out to be stronger than expected. They will continue to conduct more tests throughout the day.
In Fresno State, Orrin Winnig joins us now with more on that story. Orrin?
But up at Fresno State, they were testing a new foam. An inventor from Terabella believes he's discovered a product that can help save buildings and lives. Imagine tremors ripping through historic Fresno.
It's about 18,000 now. 18,000 now.
In a lab at Fresno State, scientists compressed a brick wall wired to computers.
I won't be surprised if it cracks in the base. It cracks in the base? Yeah.
They're analyzing the effects of an earthquake for Eric Skiff. He's an inventor who believes he's come up with an epoxy, a foam that inserted in a building would make it earthquake-proof, or pretty close. Eric's dad invented something like it 30 years ago. Los Angeles even used it for its city hall. Since 1971, the building has seemed to repel earthquakes, but there was a problem with the invention.
That it contained Freon. And as we all know, Freon has been a removed substance for use in industrial as well as commercial needs.
It took a few years, but Skiff replaced the Freon with carbon dioxide. The compound injected into the brickwork hardens on the outside, adding strength, but it remains soft in its core, making the wall flexible, which means under thousands of pounds of pressure, without this new invention, the wall
It's more flexible.
Our scientists say that epoxy may have changed Fresno history. This is Courthouse Park, the heart of downtown, but few would argue that that building is the heart of this city. That honor goes to the building it replaced. In 1966, the county leveled the old courthouse. They said at the time it couldn't be retrofitted for an earthquake. Now, others of that era could get an upgrade without closing their doors. Skiff says his product could be applied while people work.
The best part about it is it saves people's lives. We're not going to have the buildings falling down.
The epoxy is called Bisfoam, and Skiff plans on distributing his product in September. Steph?
Plastic foam may save your life during an earthquake. Final testing took place on the campus of Fresno State of the epoxy called Bisfoam. The foam is meant to hold brick walls together during an earthquake. The product could eventually be added to brick buildings in California built from the 1880s through 1950.
Valley researchers may have found a foamy solution to the destructive nature of earthquakes.
What they've come up with could make shaky buildings stand tall. Action News reporter Gil Reyes has this.
Looking at is a simulation of a 6 or 7 magnitude earthquake. You'd expect to see these brick walls come crashing down, but they don't.
We were able to keep a wall completely intact under full test load application.
That's because these walls were injected with an expansive epoxy foam manufactured by Delta Plastics in Tulare County.
It increases the survivability of people exiting a building in a massive seismic quake.
The foam is being tested by the Fresno State Civil Engineering Department. It's made for use on old brick buildings. The formula is injected into a structure where it hardens. That makes the structure more earthquake-proof.
We proved that this material works and it can be used in the market buildings.
Delta Plastics says epoxy foam is a cost-effective, time-saving alternative to retrofitting old buildings that need to meet safety standards. And not just here at home. Thousands of lives were lost in Turkey's big quake last year, crushed under the weight of collapsed buildings.
They would not have had nearly the loss of life that they experienced.
Gil Reyes for ABC 30 Action News.
Well, just think of all the old buildings we might still have around here if we had that stuff then.
An amazing new product. All right. In the future, could a plastic foam save your life during an earthquake? Seismic testing is underway on the campus of Fresno State. Full-scale masonry walls have been constructed in the engineering school's structural testing laboratory. They have sprayed with an epoxy called Bisfoam, which is meant to hold walls together during an earthquake. The test walls have been stressed to see how they react.
We're keeping the bricks together, keeping the building standing, so that we have time to go ahead and have the people be able to evacuate a building, and that's the first goal.
So far, the tests are proving successful. Delta Plastics is hoping the foam could be added to brick buildings in California, buildings built from 1880 through 1950. There are about 3,000 of the buildings in the state that could benefit from this new technology, and it's happening right here in the valley.
Fascinating.
That's great.
All right.
Okay.
How much is the load, Alan? How much is the load?
Without these hinges, we would have been in trouble. That would have brick big time. That would have right there.
You're now starting what? What do you guys estimate the angle? 10%, 15, 20?
This is about 72 inch, and the maximum you can go is 5. So you're looking at 7%. The maximum you can go is 7%.
What we're doing with this bar, more stringent than what we did up there in Alameda. Now, the manufacturer is happy. Huh? The manufacturer is happy. Anytime you want to go in here, when we were up there in Alameda, we did the one push. Okay? What we're doing now is we're cracking, building.
Yes, back and forth.
Well, it's not so much that, you're getting breaking now.
I think the LVGGs are out of range already. What? LVGGs are out of range.
Yeah, I disconnected them.
Yeah.
That's way out the way we get a big hole. The hole struck infinity. And the accelerator.
Oops. Oh, we need to go. Do you want me to put it on hold?
That was just one.
This was an extra one?
It's not an extra, it was a balancing.
We can put it in hold and reconnect it. We want.
No, connecting isn't going to do us anything with that.
There's a hold and resume, so anytime there's something wrong, we can hold and fix it and resume.
do we get a point for being here? But then, look at the logical thing. Yeah. Yes. No, I understand.
Haven't we reached about the end of this?
No? See, look, you still got about an inch to go.
Yeah, it's still about. Move this way.
Remember that's what I was talking to you about? Do that with the wall. This is you break that wall up off the lower wall? Yeah, because you can have the house to work with. We'll do that tomorrow. 8:30, 9 o'clock. Start backing up.
We're getting very close to 5 inches. We're getting very close to 5 inches, Very soon, when it's cut off,
When they cut off, you have to bring it here and bring it to zero.
Right.
I don't think it's take too long. Not open.
Do it to zero, quick.
Yeah. Bring it to zero, brother.
Before it collapses.
Comes back to reset this something. Well, he's still got a few walls to show. When's he coming back? He'll be here, I think, this weekend. Okay. Can I get a call?
I'll pop it out and I'll take a copy and a copy of it.
Okay.
Sure. I want to see if I can send it down the bar.
Okay, that's fine. Just produce 2 copies, one for you and one for me, okay?
Okay. Other three, maybe.
Ooh, look at that. Oh. Getting wild. Well, we're using the whole stroke also. Okay. What are the mechanical properties of the wall? I don't think this thing will break. Boy, look at this. You know, when you reach at this stage and the wall is not, doesn't want to break.
It's just not optic foam. You're not putting weight into the structure. Imagine paving frame. That's
Look at the left up. Okay? Yeah, look at the left up. The joints, how much the joints left.
Oh, outstanding. That's great. Copy it. This wall is outstanding.
Excuse me.
Hey,
Either, pardon me, what is your name?
I'm Bill. Sorry,
Bill. Either there or on further toward that computer over there.
Yeah, Bob.
No, he wants you.
Okay.